video, please subscribe my channel. If you like it, share to your friends, and if you have any doubts, please don't forget to put it in the comment box. Hi friends, this is Anusha again with you with a new video, continuation of the topic in the lesson, the reflection of light at curved surfaces. So yesterday we were discussing about normals. What are these normals? And we have learned about it. So on a plane surface we learn about the normals. Isn't it? Normal is something line which makes a normal is a line like this, isn't it? To the plane of the surface or to a point perpendicular to that plane. See, this is normal at this point. This is normal at this point. This is normal at this point. As our second law tells that the angle of incidence is equal to the angle of reflection. It should not bend like this. Angle of incidence is equal to angle of reflection. So I want to show you with a small experiment and make you get a clear idea about the normal. So suppose this is the think this is a plane mirror. Think this is a plane mirror, and these are the normals, and these all are the normals. Normal at this point, as it is perpendicular to this, forget about all this and see this. This is perpendicular to this, and this is perpendicular to this. This is perpendicular to this, and this is perpendicular to this. Isn't it? These all, at this point, this is a normal to the surface. At this point, this is a normal. At this point, this is a normal. At this point, this is a normal, isn't it? Yes or no? Yes. Now, as we discussed yesterday, that in a spherical mirror, if the mirror is inwards, if I bend this foam in this way inwards, what you can observe? You can observe clearly. You can observe clearly that all the normals are meeting at a point. Now, from this I want to explain you that if an incident ray is making an angle here, and with the same angle the reflected ray will come out. Here the incident ray will come and the reflected ray will come out. Here the incident ray will come, reflected ray will come out. Incident ray will come, reflected ray will come out. So what happens when the mirror is inwards like this? When the mirror is inwards like this, all the reflected rays are going to meet at a point. Meeting at a point in physics, we call it as a converge. Converge. What we will call? Converge. Meeting at a point is called converge. Means nothing but meeting. In science language, you are going to call it as converge. Suppose this is a foam, isn't it? Suppose this is a mirror. When I bend like this outside, it behaves like a convex mirror. Bend outside like this. This is the reflecting surface, and these all are the normals. So what happens in this? The normals are going to diverge, means move away from each other. Converge. Concave mirror converge, coming together. Convex mirror diverging. So you are somewhere else back the mirror, they are going to meet. Somewhere back the mirror they are going to meet, and it is shown inside. We are going to drag this reflected rays all, and here we are going to make it. We are going to meet them. We are going to make them to meet here. So, you can see in concave mirror, the reflected rays are going to converge, meet at a point. And convex, the normals are not meeting, they are diverging like this, isn't it? This is a surface. If you draw like these normals, they are going to diverge. And we are going to drag it at one point and we will see that they don't really meet. Here in concave mirror, they are going to meet really. In convex, they are not going to. We are making them to meet at a point. But in a concave, they are really meeting. So let me show you in a picture form. Suppose this is the mirror. Which mirror is this? Which mirror is this? You can't say which mirror is this because I did not mark anything. It may be concave or a convex, isn't it? So if I mark it like this, back. Now, this is the part, this is the one, here is the mirror and here is the back side of the mirror. So as it is inward, like this cave, in the shape of a cave it is there. So it is a concave mirror. You can draw this concave mirror in this way also, like this. Here, where will be the mirror? This side will be the mirror. If you draw here like this or like this, both are same. You are not supposed to get any confused because here is the mirror. Here is the mirror. Convex. Convex. When you go to a convex, like this. So where we are supposed to put the, where we are supposed to coat it, this side we are going to coat it. Here is a mirror. Another way to draw is like this. So in which part we need to coat it? This part. This is convex mirror. So these both are convex mirrors. This is convex mirror and this is convex mirror. So in the convex mirror or a concave mirror, see, this is a normal at this point. 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 So from this what you can know, if you know the normal and incident ray, you can draw from any way, from any point from the mirror, you can draw the normals. Normal, this becomes a normal. So what happens? This will be the incident ray and this will be the reflected ray. This will be the incident ray. This will be the reflected ray. In concave mirror, all the rays are going to meet. See, this is concave mirror, isn't it? Where is the mirror? This is the mirror. So back, no, not to get confused. Like this. You are supposed to put like this. Okay, and see, these all are the normals I want to say. This is normal. 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 If you get clarity with these normals, I am going to introduce some terms which are very, very important in this lesson. So, let us go into it. First one, pole. Second one, center of curvature. Third, principal axis. Fourth, radius of curvature. Fifth, principal axis, focus or principal focus. And sixth is focal length. And these are represented with the symbols, very very important. These are very very important to you in reflection and reflection of rays. So P, center of curvature. C, principal axis. Radius of curvature. R, focus. F, capital F, focal length. Small f. These all are very very important. You are supposed to learn all these terminologies very very importantly. So let me discuss in a brief about each and everything. Now first we'll go with the pole. So let us first learn what do you mean by pole. I said you already yesterday that a surface is this convex and concave mirrors. Both are taken from a circle, isn't it? Spherical mirror. Both are taken from a spherical mirror. So it is a part of a spherical mirror. It is not out of the part of the spherical mirror. Remember, it is a part of the spherical mirror. And this is also a part of the spherical mirror. From the spherical mirror only we have cut it in the shape of concave and convex. So here where is the mirror? Here is the mirror. Where is the mirror? Here is the mirror. I feel these lines, oblique lines indicates that that is the back side of the mirror. Concentrate. This is the back side of the mirror and this is the mirror where you are going to see, where you are going to keep some object and you can see some image here. This is the mirror surface. This is the mirror. Here, this is the mirror. The outside like this, it is the mirror. Not this. This is the back side of the mirror. This is the mirror. So, as it is a convex mirror, which mirror is this? This is convex mirror. Why? Because the mirror surface is here. The mirror surface is outer surface like this. And it is taken from a spherical mirror. So, this is taken from the spherical mirror. The center of the spherical mirror is going to be your center of curvature. The center of the spherical mirror is going to be your center of curvature. What do you call it as? Center of curvature. It is not linked with the mirror. It is no way considered with the mirror. No, in the mirror part you are not supposed to draw. Only it is the center of the mirror. So what is the geometrical center or center of the mirror called? It is pole and it is indicated with P. Here also the center of the mirror is called as pole, P, and here it is center of curvature. The pole is center of mirror. I am repeating it again. This is the midpoint of the mirror. Pole is something which is midpoint, geometrical center of the mirror. And C is center of curvature. The center of curvature is related to the spherical mirror. Center of curvature, the midpoint of the spherical mirror. Here, the midpoint of the spherical mirror is called as center of curvature. And next, principal axis. Here M dash is nothing but your mirror. M dash here also. M dash is your mirror. M dash is your mirror. And C, as I said here before, C, center of curvature. Principal axis, as the name itself indicates, it is an axis. The name itself indicates it is an axis, means a line passing from the pole. is called as a principal axis. You can extend this principal axis. Remember, you are not supposed to extend anything except this principal axis. You can extend it. You can extend it. Next, radius of curvature. What is this? Radius of curvature. Radius of curvature is nothing but distance between the pole to the center of curvature is radius of curvature. The distance between the pole to the center of curvature is radius of curvature. Here also the same. The distance between the pole to the center of curvature is your radius of curvature r. Pole to the center of curvature is radius of curvature. From the pole, the distance between the pole and the center of curvature is radius of curvature. Pole and the center of curvature. Pole, from the pole to the center of curvature is radius of curvature, is represented with an capital R. This is P, this is C. This is the principal axis. Got it? X, Y we have represented here in this we are represented with X and Y. This is concave. I am repeating again. This is concave mirror. This is concave mirror. The outside is oblique like this, and this is the center of curvature, which is taken. The curvature of the center of the spherical mirror you have taken, and pole is something which is related to the mirror. Midpoint of the mirror is called as pole, and this is the distance between the center of curvature to the pole is radius of curvature. Here, the distance between the center of curvature to the pole is radius of curvature. You can see clearly in the convex mirror. In the concave mirror, you can observe that this is the mirror, right? Here is the center of curvature. But in convex mirror, here is the mirror. This is the mirror, isn't it? This is the mirror. This is the blue one is the mirror. And this is the pole. But center of curvature will be the back of the mirror, as you have taken from the spherical mirror, isn't it? So here it will be the center of curvature. And about this capital F is nothing but focus. As we have discussed previously, the focus I will draw here and I will explain you. Cx, Y. What is this mirror? You can't say any mirror now. Now, if I draw like this, yes, it will be clear to you. This is a concave mirror. This is, here is the mirror. Cave, like this, cave. Cave, no? Concave, inside the mirror will be. Like this, the mirror will be. So, the principal axis, this is the, P is nothing but pole. P is nothing but pole. And this is center of curvature. A line passing through center of curvature and the pole. The line passing through center of curvature and the pole is called as principal axis. Is call it as principal axis. Center of curvature is the center for the outer sphere, isn't it? Spherical mirror. Outer spherical mirror will be there, na? It will be the center for that. This is not the center for the mirror. This is the center for the mirror. I said you already. So our M dash will be the mirror. Now, this is the principal axis. Let us name for the principal axis also X, some Y. And as we have discussed already, in the concave mirror, what happens to the normals? They are going to meet at a point, isn't it? After reflection. Don't think these are normals they are meeting. No, for your understanding, I am showing that the reflected rays which are coming from here, The reflected rays which are coming from here are meeting at a point. Let me show this. At this point, this will be the normal. At this point, this will be the normal. This normal is same. This normal is same. This normal is same. So, if an incident ray falls like this, if an incident ray falls like this, isn't it, with arrow like this, they will get reflected, isn't it? They are going to get reflected. When incident ray falls on the normal, they are going to get reflected. When incident ray are going to fall on the mirror, they are going to get reflected back. Like this, isn't it? The reflected ray should have arrow, so that you should not get confused. This is the reflected ray, isn't it? This is the reflected ray. And here, again, incident on this ray is incidenting like this. So it is getting reflected back like this. Isn't it? In concave mirror as we saw, these all, see, this is the incident ray like this. The nose should be like this. As it is incidenting now like this, it is going to the mirror now like this. You are supposed to put like this. The sharp end of the arrow should be this side. And as it is coming towards it now, the sharp end of the reflected ray should be like this. Like this, isn't it? So all the reflected rays, so if they will make the same angle, isn't it, as you have learned? So they are making the same angle when, as we saw in this concave, when it is bent like this, all the reflected rays are going to join, isn't it? Here all the reflected rays got joined. So this is said to be focus, capital F. That is focus, capital F. So each and every distance, you are supposed to draw from pole itself. So pole to center of curvature, pole to focus, pole to something. With pole, from pole you need to take it as. So from pole to focus, focus or principal focus. Pole to principal focus or focus. The distance between the pole to principal focus. I repeating again. Pole to principal focus or focus. Focus means all the reflecting rays are meeting at a point, isn't it? This is said to be focus. This is said to be focus. So what? This is called as focal length. What it is called? Focal length. It is called as an focal length. And focal length is represented with a small f. Focal length is represented with an small f. Now what is the radius of curvature? Radius of curvature is this. From pole to center of curvature is radius of curvature. And the length between the pole to focus, where all the rays are meeting, it is focal length. Then the focal length should be there for the convex also, isn't it? Focal length should be there for the convex also. So how we will draw the convex focal length? How we will draw convex focal length? See. How you will draw convex focal length? How you will draw convex focal length? See. This is the, what mirror it is? No. Now, yes, it is convex mirror. This side is the mirror. So P will be here. And this is the surface of the mirror. This is the surface of the mirror. This is the pole. And center of curvature will be out of the mirror, isn't it, for the convex? And this is the principal axis. This is the principal axis. This is the principal axis. This is the center of curvature. Now, all the lines, as somewhere the image is here, or some source is here, or the rays are first, they are going to focus on the mirror, isn't it? They are going to fall on the mirror, yes. These are the, isn't it? So, they are going to get reflected. They are going to get reflected. Arrows, you don't forget to put it. Arrows, you don't forget to put it. They are going to meet? No, they are not going to meet as we saw here. They are not, they are going to get diverged like this, isn't it? So, when you drag it, these reflected rays, when you drag these reflected rays back the mirror, somewhere they are going to meet. This point is called as here focus. Again, the distance between pole to the focus is focal length. It is represented with a small f. Small f. Now, what is the radius of curvature here? From the pole to the center of curvature is radius of curvature. R, capital R. I hope you followed it. Isn't it? The arrows are compulsory to differentiate incident ray to the reflected ray. Again, this is a mirror. Which mirror it is? It is a concave mirror, as the mirror is inverse. The center of the mirror, the midpoint, the geometrical midpoint is called as pole. And it is taken from a spherical mirror, isn't it? The center of the spherical mirror, the outer spherical mirror is your center of curvature. The rays, after incidenting on the mirror, in the concave mirror, they are going to meet at a point. This point is called as a focus. This point is called as a focus. And the distance between the pole to the focus is focal length. And the distance between the pole to the center of curvature is radius of curvature. And this line which is joining both center of curvature and the pole is called as a principal axis. And then there is a convex. They are going to diverge, isn't it? They are going to diverge. And this is the pole. And in this, don't forget, don't get confused, it will fall out. Remember, convex out. The center of curvature and will be out, and the focus will be also out only. So they are not going to meet, but we are going to drag it back and make them to meet at a point. They are diverging, isn't it? These are converging really. These are not converging really. They are diverging, but we are making it to converge here. This is called as a focus. The distance between the pole to the focus, capital F, is focal length. Distance between the pole to the center of curvature is radius of curvature. And the distance between the pole to the focus is focal length. Distance between the pole to the center of curvature is radius of curvature. All the things you are not supposed to take from the pole itself. From the pole you are supposed to take everything. From the pole to the focus, we need to consider pole as the main important one, and from the pole we are going to measure each and every length. R is equal to, now radius of curvature, R is equal to 2 into F. If you get in any problem, R, radius of curvature, you need to find focus. Then focal length. So you are supposed to R by 2 is equal to F. Radius of curvature is double to the focal length, 2F. So in the problems, this formula is important to it. Where R is the radius of curvature, F is the focal length. And with this, we end it.